Have you ever noticed something weird about your internet? You can stream a 4K movie on Netflix in like 3 seconds. You can download a massive Call of Duty update while scrolling through Instagram. But then you try to upload a simple video to Google Drive and suddenly it's like you're back in 2005 with dial-up. Your laptop sits there spinning that little circle for what feels like forever. What's going on here? Your internet company advertises blazing fast speeds, and they're not totally lying. You are getting fast speeds, just not when you need to send stuff out, only when you're pulling stuff in. Here's what nobody tells you about your home internet. It's not actually broken. It's not even slow. It's specifically designed to be lopsided. And in the next 15 minutes, you're going to understand exactly why your internet provider built it that way and why this matters way more than you think. So let's talk about something you've probably noticed but never really questioned. Picture this scenario. You're trying to upload your vacation photos to iCloud before Thanksgiving dinner. You've got maybe 200 photos from your trip to Florida. Not even huge files, just regular iPhone pics. You hit upload and then you wait. And wait. Meanwhile, your cousin is in the other room streaming The Mandalorian in 4K without a single buffer. How does that make any sense? You're both using the same Wi-Fi. You're both connected to the same internet. But somehow, Netflix can shove an entire movie into your TV instantly while your photos crawl through the internet like they're stuck in traffic. Here's what's really happening. Your internet connection isn't actually one thing. It's two completely separate highways. One highway brings stuff to you. That's your download speed. The other highway takes stuff from you. That's your upload speed. And here's the kicker. Those two highways are totally different sizes. Think about it like the drive-thru at Starbucks. They've got multiple lanes funneling into the pickup window because most people are just grabbing their coffee and leaving. But there's only one narrow lane for people trying to get into the drive-thru in the first place. Why? Because Starbucks knows way more people want to receive coffee than deliver it. Your internet works the exact same way. This isn't an accident. This isn't your internet provider being cheap or lazy. This is a deliberate choice based on how actual humans actually use the internet. And once you see why they designed it this way, you can't unsee it. Let me blow your mind for a second. The average American spends about 7 hours a day on the internet. 7 hours! That's more time than most people sleep. But here's the wild part. Of those 7 hours, probably 6 hours and 50 minutes are spent downloading stuff, streaming shows, scrolling TikTok, loading websites, watching YouTube videos just like this one. All of that is downloading, uploading, maybe 10 minutes a day, sending some emails, posting a few Instagram stories, uploading that Google Doc for work. That's it. Most people spend like 98% of their internet time consuming content and maybe 2% creating or sending it. So your internet provider looked at this and made a business decision. They said, okay, we've got limited bandwidth to work with. We can't make everything super fast. So where should we put the speed? And the answer was obvious. Put it where people actually use it. This is what I call the consumer priority pattern. Your internet is literally built around the assumption that you're a consumer, not a creator. You're there to watch, not to broadcast. To download, not to upload. And for most people, most of the time, that assumption is totally correct. But here's where it gets interesting. This design choice creates real consequences that most people never think about. It shapes what you can actually do on the internet. It determines which activities feel smooth and which ones feel painfully slow. And it's the reason why certain people, gamers, streamers, anyone working from home gets so frustrated with their internet while everyone else thinks it's fine. Let's get into how this actually works under the hood. When your internet provider runs a cable to your house, whether that's a phone line, a coax cable, or a fiber optic line, that cable can only carry so much total data at once. Think of it like a pipe. The pipe has a fixed width. You can't magically make more stuff flow through it without making the pipe bigger. So what does your internet provider do? They split that pipe into two separate channels. One channel for downloads coming to your house, one channel for uploads going from your house. And here's the crucial part. They don't split it evenly. With most home internet connections, they give you something like 70 or 80% of the pipe for downloads and only 20 or 30% for uploads. Sometimes it's even more extreme. You might get a connection that's advertised as 300 megabits per second, but when you look at the fine print, that's just the download speed. Your upload might only be like 10 or 15 megabits, a 20-to-1 ratio. This setup has a fancy technical name. It's called asymmetric bandwidth allocation. Asymmetric just means unequal, not the same on both sides. Your download and upload speeds are deliberately mismatched because that's what works best for how most people use the internet. Now, this asymmetric design shows up in different ways depending on what kind of internet you have. Let's start with DSL. That's the internet that comes through your phone line. Old school technology at this point, but millions of people still use it. DSL works by sending data through copper telephone wires using different frequencies. Think of it like a radio. Your radio can play different stations at different frequencies, right? FM at 101.5, another station at 95.3. Same idea. DSL uses high frequencies for downloading and low frequencies for uploading, and they can both happen at the same time without interfering with each other. But here's the thing. Those copper phone wires were designed like 60 years ago for voice calls, not internet. They can only handle so much data before everything falls apart. So DSL providers looked at their limited capacity and said, okay, we're going to give most of this to downloads because that's what people care about. The result? DSL download speeds might be decent, like 25 or 50 megabits if you're lucky, but upload speeds are usually terrible, like 1 to 5 megabits. Enough to send an email, barely enough to upload a photo, definitely not enough to live stream yourself playing Fortnite. Then there's cable internet. This comes through the same coax cable that brings you TV channels, same physical wire. And cable internet uses a similar trick. It splits the available frequencies into channels. Some channels are for downloading, some are for uploading. Most are for downloading. Cable internet is faster than DSL because coax cables can handle way more data than old phone lines. But the asymmetry is still baked in. A typical cable connection might give you 200 megabits download and only 10 megabits upload. Still a huge gap. Why? Same reason. The cable company knows you're watching Netflix and scrolling Twitter way more than you're uploading stuff. So they optimize for what you actually do. Now, fiber optic internet is different. Fiber uses pulses of light traveling through glass cables. It's way faster than copper wires and it can handle massive amounts of data in both directions. With fiber, you could have symmetric speeds like a gigabit download and a gigabit upload. Some fiber providers actually do this. Google Fiber, for example, usually gives you equal speeds both ways. But even with fiber, many providers still give you asymmetric speeds. Why? Because most people don't need symmetric speeds, and the provider can serve more total customers if they're not dedicating half their network capacity to uploads that barely get used. This is what I call the optimization trap. The system is optimized for average behavior, and that optimization works great for the average person. But it creates real problems for anyone whose needs are even slightly different from average. Let me tell you about Marcus. Marcus is a video editor who works from home. He creates content for YouTube channels and corporate clients. Every single day, Marcus needs to upload massive video files. We're talking like 50 or 100 gigabytes, raw footage from 4K cameras. Marcus has cable internet with 300 megabits download and 10 megabits upload. Sounds pretty fast, right? 300 megabits is legitimately quick. But here's what Marcus actually experiences. When he downloads stock footage for a project, it's instant. A 10 gigabyte file downloads in like 5 minutes. Beautiful. But when he tries to upload his finished video to his client, that same 10 gigabyte file takes like 2.5 hours, sometimes longer if his roommate is watching HBO Max at the same time. 2.5 hours of Marcus sitting there watching a progress bar, unable to start his next project until this one uploads. Marcus is doing everything right. He's got decent internet, he's not being unreasonable, but the system wasn't designed for someone like him. It was designed for someone who downloads a bunch and uploads almost nothing. And because Marcus's actual usage pattern is flipped, he's constantly frustrated. Now compare that to Jessica. Jessica also works from home, but she's in customer support. She spends her day on Zoom calls, browsing help articles, maybe sending some emails. She streams Spotify in the background. She scrolls Instagram during breaks. Jessica has the exact same internet as Marcus. Same provider, same plan, same speeds. But Jessica never notices the slow upload because she barely uploads anything heavy. Her Zoom calls only need like 3 megabits of upload for good quality video. She's got 10 megabits available, no problem. Her internet feels perfect. Notice how Marcus and Jessica have identical internet but completely different experiences? That's because the internet is optimized for Jessica's usage pattern, not Marcus's. The system assumes you're Jessica, and if you're not, you're going to have a bad time. Here's what makes this even more interesting. This whole asymmetric design made perfect sense when it was created. We're talking about the late 1992, early 2000s. Back then, the internet really was mostly about downloading. People checked email, browsed websites, maybe downloaded some music on Napster. There was no YouTube, no live streaming, no cloud storage, no video calls. The idea that regular people would need to send large amounts of data, that seemed ridiculous. Uploading was something businesses did, something servers did, not something normal people in their homes needed. So when internet providers designed their networks, they built them around consumption, not creation. And for like 15 years, that worked great. It was the right choice given how people actually used the internet. But then something shifted. Social media exploded. Everyone got a smartphone with a camera. YouTube made everyone a potential creator. Cloud storage became normal. Video calling became essential. Suddenly, people were uploading stuff. A lot of stuff. Way more than anyone predicted. The infrastructure didn't change, though. We're still using the same basic asymmetric model that made sense in 2002. Your internet is still designed like you're just passively consuming content, even though you're probably creating and sharing way more than people did back then. This is what I call the legacy lock-in pattern. The system was designed for an old version of how people behave. That behavior changed. But the infrastructure is expensive and slow to update, so we're stuck with a design that's increasingly mismatched to actual usage. And here's the uncomfortable truth that nobody wants to admit. Internet providers kind of like it this way. Not because they're evil or greedy, but because asymmetric bandwidth is economically efficient for them. Think about the math. Let's say your neighborhood has 100 houses. If everyone had symmetric gigabit internet, 1 gigabit download and 1 gigabit upload, your provider would need to provision 200 gigabits of total capacity for your neighborhood. That's expensive. Requires more equipment, more maintenance, higher costs. But if everyone has asymmetric internet, 1 gigabit download and only 35 megabits upload, suddenly your provider only needs to provision like 135 gigabits for the same neighborhood. Way cheaper. And for 90% of users, it works just fine because they're not using their upload anyway. Your internet provider isn't stupid. They know exactly what they're doing. They're making a calculated bet that most people won't notice or care about slow uploads because most people don't upload much. And they're mostly right. But here's where this really starts to matter. There's this whole category of activities that are incredibly sensitive to upload speed. And if you do any of these things, slow upload makes your life miserable. Gaming is the perfect example. When you're playing Call of Duty or Fortnite online, you're not actually downloading that much data. The game is already installed on your PlayStation or PC. What you're doing is constantly uploading your actions to the game server. Every time you move, every time you shoot, every button press, that's upload data. If your upload is slow or inconsistent, you get what gamers call lag. Your character stutters, your shots don't register. You die because the server didn't get your input fast enough. And this happens even if you've got crazy fast download speeds. Download doesn't matter for gaming. Upload is everything. Live streaming is the same deal. If you're streaming on Twitch or YouTube, you need to upload your video feed in real time. You need like 6 to 10 megabits of upload for good quality 1080p streaming. If you've only got 10 megabits total upload and someone else in your house is on a Zoom call, your stream is going to drop frames and look terrible. Video calls are upload heavy too. That Zoom meeting where everyone can see you, you're uploading your video and audio constantly. If your upload is maxed out because someone's backing up photos to Google Drive, your Zoom call freezes and you look like a pixelated mess. Working from cloud storage, uploading documents to Dropbox or OneDrive, sending large files to clients, all upload-dependent activities that feel painfully slow on asymmetric connections. This matters because the internet is fundamentally changing. We're moving from a consumption-based internet to a participation-based internet. More people are creating content, working remotely, live streaming, gaming online. The things that require good upload speed are becoming normal daily activities, not niche hobbies. But the infrastructure hasn't caught up. We're trying to do 2,025 activities on a network designed for 2,002 behaviors. So, what's really going on here? It's not actually about technology at all. It's about assumptions. Your internet provider makes assumptions about how you'll use the internet. They assume you're mostly consuming, not creating. They assume you're watching Netflix, not uploading to YouTube. They assume you're browsing websites, not live streaming gameplay. And for the average user, those assumptions are still mostly correct, which is exactly why nothing changes. There's no massive outcry demanding symmetric speeds because most people genuinely don't notice the asymmetry. But here's what this means for you. The question isn't whether your internet is fast or slow. The question is whether your internet matches what you actually do. If you're Jessica, mostly downloading, rarely uploading heavy files, then asymmetric internet is perfect. You're getting exactly what you need. But if you're Marcus, constantly uploading large files, working in the cloud, live streaming, then asymmetric internet is a constant source of frustration. And it's not because you have bad internet, it's because you have the wrong internet for your needs. The people who succeed with home internet don't have faster speeds. They understand this asymmetry and work around it. They schedule large uploads for overnight when no one else is using the connection. They upgrade specifically to plans with better upload speeds, even if the download speed barely changes. They understand that the advertised speed always, the download number doesn't tell the whole story. Some people even pay for business tier internet at home specifically to get symmetric speeds. Costs more, same physical connection. But the business plans often have way better upload because businesses actually need it. This is the part that changes everything. Your internet speed isn't one number, it's two numbers. And the one that matters depends entirely on what you're trying to do. For most people, most of the time, download is what counts. But for an increasing number of activities, gaming, streaming, cloud work, video calls, upload is everything. And once you see it this way, you start noticing the asymmetry everywhere. You see why your Instagram story uploads slowly but loads instantly when you refresh. You understand why your Zoom call freezes when someone starts a backup. You get why streaming to Twitch requires a completely different kind of internet than streaming from Netflix. These patterns aren't personal failures. They're predictable consequences of a system that's optimized for average behavior. But now that you understand the asymmetry, you can actually make informed choices about your internet instead of just buying whatever sounds fastest. So here's what we've uncovered. Your internet has two completely separate speeds, download and upload. And they're deliberately unequal because that's what works for most people most of the time. This asymmetry made perfect sense when the internet was mostly about consumption. It makes less sense now that creation and participation are normal activities. But the infrastructure is slow to change because for most users, it still works fine. The question isn't whether you can get faster internet. The question is whether you'll recognize when the asymmetry is causing your problem. Because now you know it's not about total speed, it's about having the right speed in the right direction for what you're actually trying to do. So next time your upload crawls while everyone else streams without issues, ask yourself, am I trying to use consumer-grade internet for creator-grade activities? Because once you see that mismatch, everything looks different.